Hey guys, what's up? It's Soft coming at you with your first ever tutorial. Well, maybe not first ever, but first ever maybe for assembly language on the Atari 7800. Most people like to code in 7800 Basic, but we're going to be learning how to do it in assembly language because, yay, assembly language. But it's actually pretty cool. You can actually do a lot of cool stuff with it. For example, here's The Legend of Naomi. It's my game from 2025. Looks like this. It actually got nominated for the Zero Page Hunger Awards, and would you look at that? It is completely done in assembly language. None of this was done in 700 Basic. The whole thing was done in assembly language, and you can get the source code over at Atariage. But that's not where. But we're not here. We're not anywhere close to that. We're just trying to put graphics on the screen, and right now we've got our blank screen right here, and all the stuff you're gonna want to have it copied. Um, don't like do all this. All this is basic stuff. Meeting the audio, setting up your DLL. This is all basic stuff. You need this. But there is one thing which people do forget is that there's more than 12 DLLs, right? So you're gonna want to have a blank DLL. Like how much RAM did we use? Um, yeah, we're gonna have. So we might actually not want to put it up here because if we do put it up here, then that might cause problems. So you're gonna want to insert. I recommend putting it at hex 2100 because you're not gonna be doing anything with that RAM up there. So now our DLL's up there instead. That's actually where the stack's located, but that's besides the point. So the first thing you're gonna want to do is have your equates table, right? And have your code set up. And don't worry, I'll be posting all of this code over on the Atariage website, and I'll link to it in the description of this video. Um, so the first thing we're gonna want to do is set up our blank DLLs. So a blank DLL basically tells the 7800 do nothing. We don't display anything here whatsoever. So at our blank DLL, let's have it at hex 2000. Blank, yes. And so we need no, 3 bytes for our blank DLL. Because again, a DLL is 3 bytes. 1 byte to tell how big it is and if we should do anything. Um, then we need another byte. Then we need our 2 pointer bytes. So then we need a few more things. We need it to be blank after this, right? So blank DLL, blank DLL. So H4F, SCA hex 21. As you can see, me casually forgetting my label names. And that's okay. You will do this too. Or maybe it's just me, but trust me, you're more than likely going to be doing this as well. So now we've got our DLL right up here. So all this is set up, which is good. We want that. That's a good thing. So back to Legend of Naomi. You can see I'm doing all the same stuff here, right? Like if you look down here, you'll see that I'm doing all the same stuff. Granted, this is all a bit messier, and actually, you're gonna want to have this too in case you want to have a score, but we're just putting graphics on the screen. We'll get to that later. So, the next step of your coding adventure is, well, how do I put stuff on the screen? And the first thing is that actually most people call this back, background, not color background. It's just a habit of mine, but the first thing, to make sure your program is working, just do hex LDA, and if your screen goes white like this, or tan, if you want it white, then you do this. Um, then you know it's working. This is good. So how do you put graphics on the screen? Well, it gets complicated because 7800, well, it's very different. You don't have any sprites. There's no traditional sprite count. It's a trade-off. The trade-off is that if you want a game like Robotron 2084, you can easily put 32 sprites or more on a single line and expect no flicker at all. Um, because it's just that powerful. In fact, look at some of the example programs from 8-Bit Workshop in C, not assembly, but in C, and we can have, and look at all this. Granted, they didn't program this very well, but I bet you that a more experienced programmer could easily do this without any flickering whatsoever. Um, but for example, if you look at its serious time 4 here, all this is sprites. Like all this background here is sprites. So back to our program. It's not that serious time 4. Our first program here. So how do we do that? Well, the trade-off is that it's a bit more complicated for the programmer. So, for example, I'm just going to be putting in a simple DLL, a 5 byte, or 5 byte DL slash, 5 byte DL slash sprite. Well, actually, it's not DL, it's a 5 byte sprite. So it's 5 bytes. First is the low byte. Um, second is write mode. Third is high byte. Fourth is palette width, and fifth is expos. Now you might be saying, wait, where's the Y post? And that's the funny thing. There is none. It's actually the high byte here. So you know what this means? This means that first off, all our graphics has to be offset by one page. A page is 256 bytes, by the way. So we'll get to graphics formatting too. In fact, I have these I have this tool here called Antrax, which will allow me to do all my Atari graphics here. Like, we'll get to that. But trust me, graphics on the 7800 is great. As you just saw, Legend Naomi. In case you didn't see it, here's Legend Naomi. Looks great. It's a great game. Like, we can make games like that look like this and much, much better. Like, for example, Muddy Funster's games. All of his games look great. He goes by the name Muddy Vision, but on Atari he goes by Muddy Funster. Um, his actual name is Lewis, and he's a great guy. But he mainly uses 7800 Basic, and that's okay, by the way. You can use whatever language you choose. I'm choosing to use assembly language because that's what I use. I don't use other. I don't use 7800 Basic. I don't use C. I do use C in the modern world, but that's besides the point. So back to here, we want to make our sprite. So where do you want to put it? Well, you see all these lines. See all this? This is DMA. So you can see where it's reading from. See how it's reading from hex 2580. So if we want to sprite and around this area, we can write to 2580. So let's do that. So first byte. So I already have some graphics defined down here. Granted, it's in the 1 byte. It's in 1-bit format. So it's just a line. But you see all this graphics here, so let's use that graphics. So 0, stay 80, and write mode. The write mode is basically telling the 7800 what write mode you want to put it in. 7800 has 4 different graphics. 7800 parameters. If you go to the 7800 development documents here, the 7800 software guide, this is an excellent guide. Um, and we have 6 modes. They're detailed down here, but this is the mode that most games will use the most. Then we have the high color mode, which looks like this, allows you to have 13 colors instead of just 3. Well, 12 colors instead of just 3. Then we have, this is the high res mode. This is our 1-bit monochrome mode, and we're going to be using that. So, so we're not going to need any special write modes. And as you can see, nothing showed up because we need this. And now, lo and behold, our sprite in the top in this corner here it showed up. And if you want to move it if you want to move it horizontally, that's quite easy. We can just do this. 40. In fact, we can actually get rid of this line of code entirely. And now, our sprite is moving way too fast. It's moving very quickly. Um, that's way too fast. So the second thing you need to set up is a wait for command. So there's 2 ways to do this, but the best way to do this is to go back up here and insert a little piece of code. So before I go to the blank DLL loop, we're gonna have LDAXCF. So this byte is special. It tells Maria that hey, we want to interrupt here. We want to interrupt just after the screen's been drawn because remember, you see all this black space here? This is CPU cycles lost. This is stuff that we don't want to have to we don't want to have stuff running up here because our CPU is slower because of all this black space. But if we go down here, now you can't really tell right now because there's only one sprite on screen, but if you go to a game like Legend of Naomi, for example, that's a lot. And it gets even worse once you start have stuff moving around, like you see all that black space? Yeah, those are CPU cycles we lose. So we want to start a code down here. So, and if you see this name change, don't worry. That's just a glitch in this editor. I'm using this editor, 8-bit Workshop, because it's simple to understand, and I'll be posting all my tools under the Atariage post where this is located. So the second thing you're going to want to know about the 700 is that it has a ton of colors. You have 256 colors to choose from, so don't worry, you won't be running out of that. In fact, if you want to do something simple, you can do this. And now you can see all those colors going crazy up there. I quite like the 70 color palette. It's one of my arguments as to why the 70 is the most powerful 8-bit console of the big three. Not the NES, not Super Nintendo. It's actually the 70. Um, despite what their Donkey Kong port might let you think. But anyways, so what we're gonna need to do is back to here. And if you did it right, now if you go up to here, I didn't do it right, as you can see, but if you do it right, we'll have an NMI, and the NMI basically tells it, oh, hey, stop doing what you're doing. We want to interrupt the CPU and do something special. Um, Clearly, I screwed it up, but I'll figure it out. But back to, eventually, this is that's supposed to work. Um, but here, and in case you are like me, and you're like, wait, why isn't my code working? We can always go back and find out why it's not working. For example, see here, it is working. So why isn't it working here? Oh yeah, I see. Because I'm actually doofus. You see this? Should be actually this. Now if we go here, now it's working. So make sure, remember, don't be a doofus. This means hexadecimal. This means decimal. Hexadecimal is base 16. Decimal is base 12. Don't be a doofus. But now that you see it's working, you see this blue, you see this purple stuff? That's our interrupt. And if you go back here, I conveniently set up this wait for byte here. You can see it's incrementing, and that's useful for us because what we can do now is we can have a wait for, and we can do jstar do wait. What that will do, actually, you won't even want that. Do wait. Now, what this will do is before before all of this happens, the CPU is just spinning around, being like waiting for this purple stuff to happen. And if it does, then this code runs. So now we're doing it once per frame, and if everything's working, and you insert this code, only a wait for this one, a CLC 80 plus one. Wait, your little line here will be flickering, or whatever you choose. Like I can come down here, change all the graphics. Like I can change it to an X. And now we have our little X here instead of a blank space. So, but yeah, this is, if you've got it working, this is good. But how do we do vertical movement? I don't want to have to do this. Look how much that moved. That's quite a bit. So how do we do it? Um, it's quite simple. Well, not simple. And that's where the multi-sprites come in. Now, here's the deal. Multi-sprites allows you to move finely up and down like this. But it's complicated. Look at all this. It's a big mess. And if you want to do it fast, like Robotron speed, it gets worse than this. Um, this basically is telling you, it basically tells you how to process sprites correctly. So, if we want to go back here, insert this, and copy it, insert into our code. Don't feel any shame for doing this because, trust me, I've already done this enough. I've given this code to people before, so you're not the first, you're not the last. So don't feel bad, because trust me, everybody has done this at least once if you want to code in assembly language. So going back to our first program over here, let's delete this and make a new subroutine called do do graphics. So over here, we're going to want our do graphics. And it's not working right because, well, first off, we didn't tell it how many sprites we need to process, so it's trying to process 256 sprites. That's way too many, so, and how many is it still doing? Should not be doing that many. Um, it's important that if you insert code, you know what it does first. So, I see. It's also handling this. That's why it was flashing. So now it's stable. And you can see, just two sprites alone, it already takes up a lot of it takes up a lot of time. If we want to do more sprites, like even just 16 sprites. Look at all that. Look at all that. That's a lot. And so more experienced coders will write their own, which will allow us to do more complicated graphics. So back to here. This is useful to keep around. See, as you can see, I've already done it here. There's actually a second type of sprite, a 4-byte sprite, and unless you're switching write modes a lot, then you don't need 5-byte sprites. Um, unless you want to have like character mode or any of that stuff, you don't need 5-byte sprites because 5-byte sprites take up an extra half cycle. I know that sounds like so much, an extra half cycle. What a travesty! But um, extra half cycle of CPU stuff. And of course, Maria always rounds up. So Maria operates on 4 times the CPU clock speed, and graphics DMA operates on three three times slower than Maria, which is still faster than the CPU, which is 4 times slower. But regardless, you always want to push out as many cycles as you can from Maria. So we'll get to 4-byte sprites is a very simple. Instead of having the write mode here, we'll get rid of this and insert in. Well, before we get and we'll insert in the PAL width byte. But before we get to that, just make sure it's working. Go back to here, change it back to 2. We don't need 16. What are we? Space Invaders? Um, what am I missing? And yeah, if it's working, you can do something like this. And we don't need this anymore because our graphics stuff, our do graphics, has a convenient little increment frames down there. And actually, we don't need to get rid of that, actually. Um, but as you can see, our little first program here, and if you know, and to make sure it's working, then what you want to do is just go back down here, see where it says Y post, just instead of having the number 64 or hex 40. When you see a dollar sign, think hex because that's what it is. Do something like this. Frame. If it's working, then it will move down, and then it'll mess something up. You'll see it mess up down there. And don't do that because then you will absolutely fry your display list and a whole bunch of stuff you don't want happening will happen. because what we didn't do is we need to define a little safe area down here, just in case something were to happen. Um, you're gonna want to do something like this. Well, we didn't do it here, but back to our. So now if we go back here and watch it increment, now it doesn't do anything, which is correct. It's not causing anything goofy to happen over here. It's simply going down and then disappearing, which is what we want. Now the way this works is you see all these little divots? That's the end of one DLL. Um, so the sprite straddles these DLLs by using something called holy DMA. Um, holy DMA is very useful. Always have it enabled. If I disable it, we're we're not just or that's not the disable for it. I thought that was the disable for it, but um, always use holy DMA. If you don't, then very goofy stuff will happen, and you'll be reading. You're literally losing code space because you need to blank that out with zeros otherwise. But we'll get to holy DMA another time. That's for advanced topics. Um, next topics. But if we want to go back and make another sprite, we can do that. We can do that too. And as you can see, our sprite here is now activated. As you can see, there's a little glitch, but we can always fix that. And the reason there's a glitch there is because we've managed to go past our, safe zone. So what I usually recommend for doing stuff like that is just in case you go beyond where you're supposed to, have your don't point to RAM or like normal screen memory. Point to something like hex FE00, FE40, FE80, FEC0, because, just in case. That way it'll be writing to ROM, and you can't write to ROM, by the way. ROM is read-only memory. Our our cartridge ROM starts at hex 3000, despite what this says. This is wrong. This is why I don't like to use Ape Workshop outside of if you're new. But yeah, now we have our first program, and if we want to mess around, we can do something like this and go back here and add some more graphics. And make our sprites bigger. Not sure where the other one went. Oh, I erased it. Oops. But if we want to make it bigger, we decrement this number. If we want to make it bigger still, granted, later on, you're going to want to use your graphics editors, not typing it in manually like this. Because this, this, um, this gets tiring real fast. Um, and well, um, let's just say, um, I have a bit of experience all the way. Yeah, look at this. Look at all this. Yeah, this is my first game. Don't do this. This is not good. Um, very unfun to deal with. So next thing you're gonna be wondering is, okay, cool. I got a sprite moving. How do I read the joystick? So back to this. Let's get rid of our X pose, Y pose. So now our sprite's still again. And we're gonna be doing some lax switch. Lax isn't legal instruction. I use it a ton. Basically it's LDA plus STA, LDX. And the reason this is useful is because TXA takes only 2 cycles versus LDA takes 4 cycles. And as you can see over on our side here, this is the number of cycles we use, and obviously the number of bytes we use. You'll never use more than 3 bytes per instruction. So lax switch A and Nordics 80. The the seventh byte, the seventh bit, my bad. This bit here, the seventh bit, it's our left, right, yeah, left. It's our left direction. BNE, and when it's set to 1, we're not gonna move. So when I press, oops, it's right. So when I press it, now my sprite moves. And you'll see it's moving by 2 pixel increments. That's an artifact of the way the 7000 was designed. It's really the best way to program in the 7000 is to use 160 mode. So if I change my control value to 01 instead of 11, now everything disappears because we didn't program it for 160 mode, we programmed it for 320 mode. But if I do this, now if I go here, I guess I'm wrong. Um, well, whatever. We'll get into 160 mode next. Oh, right here. My bad. This is 160 mode. Um, as you can see, it's a lot blockier than 320 mode. But with 160 mode, you get your full set of 25 colors. As you can see, with all these colors. And in 320 mode, you can't use anyone that starts PLC1, PLC3, P1C1, P1C3. All those are gone. And most games like this will use 160 mode. Here's Legend of Naomi. And if I wanted to show you what this game looks like in 320 mode, I could show you that pretty simply by doing this. And look how bad this looks. Granted, this game is meant for 160 mode, and we're running it in 320 mode. And so it looks messed up. You can still kind of make out what things are, but it's hard to. Or if you want to use the other 320 mode, this is the other 320 mode. There's 2 different 320 modes. The second one is unique, and it's different. It's different, but it's also useful. But we'll get into that next. But here's a game that's meant for 320 mode. Here's a serious time for. And granted, I'm using my own games because I know exactly how they work, not because I want to overshadow somebody else's work. but here's 0.4. Now you can see it's meant for 320 mode. If I put in 160 mode down here by changing this control value to this, now look how bad this is. Look how, if we go back, I clicked a button. But yeah, look at this. This is bad because we're only using the game's meant for only using 9 color registers, and suddenly there's 25. It's blonky and just not good. So before you start designing a game, make sure you know in mind if you want to do it for 320 mode and have less colors but more detail, or 160 mode with more colors but less detail. But back to reading our joystick, um, if you want to read that, going back here, now we can move right and left if you want to do this is up. No, it's down. So now we have our full set of directions. And now if we want to do buttons, there's 2 buttons on the 700 joystick. 700 CX24. These are the joysticks I grew up with. And despite what Atariage might tell you, they're actually very good. Um, I've used them all my life. Well, not all my life, but ever since 2022. And in 2026, I, for the first time ever, held the CX24 and, well, a 640, which is the one button joystick that everybody knows. Um, and it was stiff, and believe it or not, but I shockingly preferred the joystick that I grew up with. And that's just me. Some people like the 640, but in our case, we wanna we wanna take advantage of that second button. And they also have the D-pad controller, but you can also use other types of controllers like a Sega Genesis controller or a Master System controller, any sort of controller which supports that 9-pin configuration, you can use it. So if you don't like the CX24, but you still want to have more than one button, you absolutely still can. In fact, you can have up to 3 buttons, 4 buttons. Heck, you can have infinite buttons if you really want to. You can use one of the. You could. I bet you could make a way to use a 5020 controller with your Atari 7800. But let's be honest, you don't want to do that. 50, the 5020 controller is a flaming mess to deal with. As a programmer. So buttons. We have, well, 3 buttons, but the third button is just the bitmized or of the first 2 buttons. So if our buttons, so if our buttons are here, and one will be, and 0 will be pressed, and 1 will be not pressed, because, well, that's how it works. Well, actually, no, it's the other way around for buttons. But that's how it would work. So our 2 buttons are here. Let's get rid of this, because I'll be using the color of the sprite to demonstrate. So if we go back here, where's our, so get rid of that. Our sprite is gone. Um, so let's do LDA IMPT0. This is our button One BMI not pressed. So now if I press a button, and on here it's the space key, or it's also the X key. Now it will do something, but the other button, the shift key, or the Z key, you can't see me pressing it, but I'm pressing it and nothing's happening. So now we can have the other button. So if I press the one button, it will make it go rainbow, and if I press the other button, it will make it go black. And so we make it go rainbow and black, rainbow and black. If you want to do something different, we could do the X position and Y position. So if I move my sprite, and I can do this, and I can move up and down, which will change the color of the sprite. And now I can see the 256 different colors, right? So if I press this one button, it'll make it change color based on the X position. Nothing changes on the Y position. But if I press this other button, now it changes based on the Y position. Not the X position. X position does nothing. And if you want to do the other, if you want to do the other controller, then you could do this. Unfortunately, 8-Bit Workshop, it only recognizes one controller, so nothing we do here will do anything at all. But that's how you do something if you wanted the other controller. So now we've got our little sprite here, and that's it. That's our first program. All it is just moving the sprite around. If you want to enable another sprite, you can enable another sprite, but that's our first program. This is my first program too. In fact, you can see we just built, going back again, our multi-sprite generator. The only difference is that it doesn't change the colors. And also, instead of having a boring little X here, well, and instead of having a boring little line here, we have this X instead. And we can see how the different colors work. Um, but before I go, Sandra can do a lot more than this. So, we want more color. How do we get more color? So, because, like, look at this. If you go back to its Sears time 4, look at that. He's got more than one color. How do you do that? So we can go back here, and now I learned my lesson after that first time, and I programmed my sprites differently, but we can kind of steal the It's Sears Time sprites. If I were to click IIRC, um, the first sprite is actually just Sears. It's not, but the second sprite is Sears. Um, so what we're gonna do is we're gonna change our write mode to C0. This will tell that this is a special sprite, and we're gonna change it because I saw where it was. Our Sears guy, you can see his eye right there. Um, not pressed. We're gonna change this. F. There we go. Our little Sears guy with the wrong colors. Um, yeah, and he's too wide. If you want to make him even wider to make him way too wide, then you do something like this, and you see all the different sprites here. In fact, you can go all the way down to 0. That's a pretty big sprite. And if you want to go even wider, we can activate a second sprite. Go back up here. Um, where's our activate sprite stuff? Now, look at that. Um, seems I forgot to disable one thing. But yeah, now we can go absolutely ginormous. And you can see we can easily make big sprites. And look at that. That's a little divot into our into the amount of graphics into the amount of the DMA we've used, right? It shows you could easily change colors and do all sorts of cool stuff. And if we want to go even bigger than that, still we can. We absolutely still can. In fact, we can do 4 sprites tall instead of just 3 sprites tall. Yeah, and as you can see, our massive sprite over here. This is something you would expect from what, a Super Nintendo? And yet, we're doing it all the way back in 1984 on an 8-bit console, no less. But this is no 8, but this is just an 8-bit console, not even 16-bit. Um, and there is one limitation. As you can see, if we zoom in, you'll see that there's 2 of the same sprite. That's because to change colors, there's only 2 palettes in 220 mode using this high color mode, right? So actually to get the other set of colors, we can do that. So back to our code here, we can change our palette width byte to say instead of 0, we'll do 80. Now it's doing nothing, but what we can do instead is X C0 D4 E. So now if we press our other button, now we'll have this entirely new set of colors. So we can define a variable up here. Some of these you don't need, so let's delete all those. So going back down here, um, where is it? Here. Um, change this to color. Now we can easily switch between our two palettes. And you can also even, if you really want to, you can see what it looks like in that other mode. And look how big this is. You can see some of my graphics over here are in the 1-bit mode. For example, Radio City is a sprite, or it's not a sprite, but you can see the Wacky Warehouse, Radio City, this explosion sprite, this saw sprite, this pokey stick thing, all this was on the 1-bit mode, but all these graphics was done in the other mode. So if I actually go back a bit, so I can show you all the graphics. There you go. Like the fish sprite, the this sprite, but by far, like about half the graphics was done using the other mode. So it's like sincere sprites, turbo. Yeah, I was still using turbo at this point. The mushroom, these we need two of them because the other palette in its Series Time 4 was used generally for the background graphics and was subject to change. So the first palette, so those first four colors would always be the same, but the others would change. The other five would change. Oh, and don't forget, we still have our if we want to custom the seizure and a seizure warning for a minute. I'll tell you when it ends. We can do this. It's just a slow flash, but I want to be safe. Anyways, now it's over. Um, but yeah, we do still have our 9 independent colors. So yeah, that's the basics on the Atari 7800. Next in the series, we'll cover more advanced stuff. And one more thing before you go, for those curious, there's a third bit, the character bit. Now I haven't set up character mode properly, but it's complicated. Um, Character mode is basically your indirect mode. Most early games you'll see which use a background will use a background like this. And as you can see, it's making all these different characters. But most late games, which you'll see look a lot better, if you can see it. Legend of Enemy 2, going back, forums. This is Atariage. If you go back here, all these all these newer games, like uh, if I can find it, Legend of Enemy 2 looks like this, looks like that. This has a lot of color. If you want to use character mode, you can see we can only have one palette, right, for every line of graphics. Now, you'll get smart. Now, let's get out of character mode, because we don't want character mode. Character mode sucks. Literally, though. It uses a lot more DMA than otherwise. Like, look at that. Yeah, we're using so much DMA that we actually successfully used more DMA than we're allotted by doing that. So we've got, say, a line 216, and like that doesn't leave much, and we're not even using it the full screen either. So we're not going to use character mode for our game we're going to make. But um another thing you'll be wondering is how to do sound. Well, sound is very simple. If you know how to do Atari 2600 sound, you'll know how to do it here. But thankfully, the 7800 designers did have one trick up their sleeve, and that is you can use any sort of sound chip with your Atari 7800 games. So if I want to use a YM2151, which is the big brother of the Sega Genesis sound chip, we can absolutely do that here and get arcade sound in our game. Um, but back to the character mode, you'll see this game. This is the final game this is the last game I intend to use character mode on because of those limitations. You'll see that it uses a lot, but the second trick I did was that, see, you can change your palette every row of the characters so that you can seemingly have more colors than just four colors. And I also had another project called It's Series Time 5. I don't know if it's still here. I think it is. Here it is, which used 320C, which is that high res mode that I was talking about with the colors. But we're using character mode here, and that's a lot. That's a lot of DMA for just this background and some sprites versus this other way with its Series Time 4. That's a lot less. This is a lot less, and you still have a lot of color. It looks like a ColecoVision game, but you still have a lot of color. So this is our first program. If you got here, granted, your graphics don't look like this because, well, I have the Tears Time 5 graphics, and you probably don't. If you do, hey, could you credit me? I'm just kidding. But if you do, well then you can experiment with the different frames I made for Cirrus and different objects like the fish and the other stuff. But yeah, and if you want to do something different, like here, let's paste in the Legend of Naomi graphics instead. That use this, the letters dot map. So let's go back to low res mode for a sec. Go back to low res mode. If I do this and changing our colors a bit. Cause see now it doesn't look right. Because well um we're using the high color mode, but we're only using we're using just a quarter of the registers. Well, a third of it, but you get the point. But we could easily switch to low res mode. I'm not gonna do it. Um, I personally prefer the look of the high res pixels because they're square. Actually, they're not quite square. They're square here because the aspect ratio is wrong, but on a real Atari 7800, they're actually thin. They're more thinnish than you'd expect. But yeah, this is our first program. If you made it here, good job. Next time we'll be covering how to make a background.